Hello, my name is Marcus, and for my project, I conducted a spatial analysis on soluble reactive phosphorus, or SRP, and the surrounding land cover in the Upper Ocmulgee watershed. So here's a quick look at my poster, but for the purpose of this presentation, I've divided the poster up into slides just for the ease of readability. Alright, so first I'd like to start with what is the significance of SRP, and it's really in that phosphorus component. Phosphorus is an essential nutrient, most notably for primary producers. So when we're thinking about aquatic ecosystems, it's just extremely important. Now, it can become a problem when SRP or other nutrients are in too high of concentration, as they enable eutrophication or hypoxia, which leads to oxygen depletion, thus harming aquatic life and leading to events like fish kills. That land use component comes in when we're considering the anthropogenic sources like agricultural runoff or sewage, and then also the transfer of these nutrients to streams. So an increased amount of impervious cover, for example, in urban landscapes could lead to higher transfer of SRP. Next, here's a look at the study area. I've delineated a watershed that's highlighted here in teal using these purple sampling locations as support points. Here, I just want to note that this the study area does cover the majority of Upper Ocmulgee, in addition to about half of the Lower Ocmulgee. Next, a brief look at my methodology. For the sources and a bit more of the details, you can read through these bullet points. But just quickly, I collected and cleaned the data, created shapefiles, which you saw in the previous figure. I delineate subbasins based on those points. I next conducted a polygon pattern analysis using the local G statistic. I then visualized the dominant land cover, notably reclassifying the land cover into three categories, those being urban, rural/agriculture, and then forested, as you'll see in a couple of slides. And finally, I exported data on the relative percentage of each of those land covers and performed a linear regression with the concentration of SRP. So here's a look at the subbasin delineation. This exact figure was done using the overall DEM file, so not specifying a port point, but instead specifying a stream network. However, I also did subbasin delineations, as you saw previously, just using the sampling points as support points. Now, regardless of the method used or the collection of sampling points I used as port points, I always ended up with this middle watershed that I'm circling right now, which contains all of my sampling points, which means I can't use subbasins to constrain the study. I overcame this challenge by simply using a 500 meter buffer. This is something that you typically see done in similar studies where we're looking at water science and GIS spatial analysis, and as you'll see in this following slide. Well, here, the first thing I want to bring to your attention is this, what's in the box here. This is what I mean by that 500 meter buffer around our sampling point. This is an example of this westmost sampling site down here, where the red pixels represent the urban land cover, that yellowish orange is rural or agricultural, and finally that green is forested. Where the overall trend we see in the study area is that we have a lot of urban land cover in the northwest, noting that Atlanta is here where I'm circling. We then see a bit of a gradient as we transition to a bit more rural and agricultural land use, finally seeing a majority forest land cover as we make our way down to the southeast. Now, as far as the SRP concentrations go, we do see a hot spot in the southwest, this cluster of sampling points, and then we see no statistical significant pattern in these northern points. So let's keep that in mind. Here is a look at those correlation graphs I mentioned prior, where on the y-axis of each of these figures is the concentration of SRP in ppm, or parts per million. And on the x-axis, we're seeing the percent, first the percent of urban land cover, next rural land cover, and forested land cover. The key takeaway here is that we have a negative correlation for urban, positive correlation for rural, no real correlation either way for forested, maybe a slight positive, where the most dominant, or you could say the strongest correlation represented by the row in each of these figures is the rural. Is also the most statistically significant, represented by the p-value, where a p-value of 0.12, you can subtract that from 1 to get an 88% confidence level. So that's the big takeaway here. Now, when we're thinking about the interpretation of this data, we're seeing that rural and agricultural land cover is the most significant. It could also, which could indicate that the SRP is primarily sourced either from simply natural sources or from agricultural runoff, at least in terms of that anthropogenic input. However, if we really want to fully characterize the patterns we see in SRP, we need either a larger number of sampling points or a bit more of a random distribution rather than the two clusters that we saw in my data set. Finally, I want to leave you with this last point where none of our experiment correlations quite hit that 90% confidence level that we really strive for in statistical studies. Now, there could be several reasons for this. It could be what I mentioned prior, a limitation in the amount of sampling points. It could also be that the 500-meter buffer was an appropriate way to indicate the land cover that's attributing to the SRP concentrations we're seeing at each of those points. That's where the sub-basin methodology will be a bit more ideal. And finally, another potential point is that there's just simply other variables that contribute to the SRP pattern. That could be what species of plants and primary producers we see at each sampling location. It could be the sources of SRP, whether point or non-point. There's just many things that you could also consider. This is kind of the idea I want to leave you with. And with that, I thank you for listening, and I hope you have a great day.